Okay, folks. So we are starting off right now. Hello, welcome. Good morning, good evening from wherever you're joining us. My name is Prithvi Raj. I'm the community manager for LitmusChaos, and I welcome you all to the Litmus Community Sync-up call, which we host every third Wednesday of the month. It's been a great month for the Litmus community, and we have achieved a lot in terms of the new release as well as what we believe we are going to come up for the upcoming release as well. And I am elated to have you all here. We see a lot of folks joining in, a lot of participants have joined us, and it's been an amazing 1 month for the whole Litmus community, and I'm excited. I'm really excited for this call, where we have a lot on agenda. But before we move on to the agenda, probably I would just like to invite, or before actually we go on to anything else, we would just like to talk about what we achieved this month and how has it been. So basically the 1.9 released, and we got in the alpha 1 version of the Litmus portal, and there were improvements to the Litmus probes, and a lot of things was suggested from the community itself. We have got Leonardo, Matt Young, Moti Asayag, and Stephen, other new members who have joined us for the community call. So a warm welcome to you all. And it's really good to see so many people joining in for the community calls, as we see, because this is what drives the community, that is members, that is people. So starting off, I would just like to share the agenda. Probably that's the first thing that I would like to share for today's call. So as you can see my screen, that's the agenda for today. So we'll be discussing the Katacoda scenarios which came up for the LitmusChaos, Kubernetes, in the Kubernetes chaos engineering courses, which was curated by Cyan from my data. Next up, we have got Stephen, who will be explaining the chaos requirements, or the chaos engineering experiment requirements that he has, along with his feedback on how he has chaos tested his application or infrastructure for the first time using Litmus. Next, we have Akram from Vscale. He'll be sharing his views or his experience while he expanded the Litmus community across France with his France meetup. And then, of course, we move on to the recap of the 1.9 release items, along with what we have planned for 1.10 release. So without further ado, before I just move on to the first agenda, I would just like to invite the new members on call to introduce themselves, or if they have something to say. So first up, we have got Leonardo Murillo. So Leonardo, please, the floor is all yours. Feel free to introduce yourself to the community.
Thank you, Prithvi. So hi, everybody. Am I audible? Can you hear me?
Yeah.
Okay. My name is Leonardo Murillo. You can call me Leo. I'm CTO for Nginx. We're a Denver-based cloud-native consulting company. I'm actually not in Denver. I'm based off of Costa Rica. This is the first time in the community meeting. I've just getting started to understand Litmus and to do some experimentation and seeing where it fits in the solutions that we're building. This is very exciting. I love to see the community growing. I love to see the presence of Litmus in the Chaos Conf that happened a couple of weeks back. So thank you, Prithvi, for inviting me to join. I really appreciate it.
Thanks, Leonardo. Thanks a lot for that introduction. Next up, we have got Matt Young, who's again new to the community, and he's been engaging with Karthik, to be honest, as far as we know, but having him in the community call is awesome. So Matt, probably you can just take up a minute or two to introduce yourself. Matt, are you there? Okay, probably we'll get back to Matt later on. So Moti Asayag, he is from Red Hat. So Moti, probably you can just take up a couple of minutes or 1 minute to introduce yourself to the community.
Sure. Hi guys, excited to join the first community meetings. We evaluated several tools before picking Litmus as our chaos engineering solution for testing OpenShift virtualization, also known as KubeVirt. I'm working together with Ondra Machacek, who proposed a patch for supporting restart for nodes. And I'm happy to be part of the community.
Awesome, awesome. That's awesome. Last up, we have Pete Travis. He's also new to our call. He's the first timer to our call. So Pete, probably you just can introduce yourself to the community and then we move forward.
Yeah, sure thing. Can you hear me okay?
Yeah, sure, Pete. We can hear you.
Great, thank you. Yeah, I'm Pete Travis. I am an SRE with Groupon. I've been looking at Litmus for a few months now. It's working great for doing sanity tests and stuff for our clusters. And glad to see that there's an active community here and a thriving project. Thanks for inviting me.
Thanks, Pete. It's a pleasure to have you here. So I also see Dillian on the call. So Dillian, probably I see that you are also joining us for the first time. Would you like to introduce yourself?
Yeah, this is Dylan. I'm a director of our cloud engineering team at EverQuote, and have a genuine interest in the Litmus project, and I think overall like what its capabilities are, and it's kind of coming in as a more of a sort of fly on the wall. Let's just sort of kind of get more cool introduction to the community.
Awesome, Dillian. Awesome. It's a pleasure to have you. So we also have Steve here, but Steve will probably move on introducing himself once he gets to talk on the agenda items. And feel free to talk if you have anything to talk about. Feel free to let us know. We can also take out time. The call is basically not just going to be based on the agenda, but we are also going to talk more about questions. We're going to take up questions or feature requests, enhancements, everything. So let's start up. Let's not waste time, and let's start with the first agenda item, that is sharing the Katakota scenarios and what Sayan has worked upon. So Sayan, the floor is all yours.
Yeah, thanks, Prithvi. Let me probably share my screen and I'll start. Can you see the screen?
Yes, Sayan, we can see your screen.
Yeah, awesome. So, hi guys, thank you for tuning in tonight or today, whichever time zone you're from. So today I'll be talking about exploring the LitmusChaos with Katacoda. I'll be talking in brief about, very brief about the Litmus CRDs and mostly about Katacoda, how we can run our chaos experiments using Katacoda. So this is me. I'm Shayan. I am an SD intern at MyData. I primarily work on the LitmusChaos project. And let's get right on to Katacoda directly. So what is Katacoda basically is, in short, it's an interactive platform where we can get tons and tons of amazing resources in terms of let's say basic tutorials, or I can say sort of tutorials about different technologies and tools. So it's why I say it's interactive is because you can basically spin up a cloud environment and you can do anything you want, like you would normally do if you are working remotely, if you're working locally with Kubernetes and other things installed. So you basically spin up a cloud environment where you'll be getting all that control on that particular environment. So it's interactive. You'll be having two panels, as we are going to see very soon. We'll be having two different panels where we'll get instructions on the left and we can execute the operations on the right. So these are some of the very basic, some of the few tools or the few courses that are available in Katacoda. Moving forward, we'll be talking about a scenario, which is the getting started with Litmus scenario in Katacoda. So what exactly is a scenario is we'll be getting step-by-step instructions or like a step-by-step guide to how you can do a certain thing. It's not just about tutorials. It can also be about examples. Like in this one, we are giving an example of how Litmus works, and you can see and preview the same example in Katacoda. So you don't have to install anything locally. You would just do it everything on the cloud environment, and you can basically see how Litmus works. In that case, this is an example. But let's say someone is coming in here for learning something, you can also do that with Katacoda in sort of a step-by-step learning process. So currently, these are the technologies which are there in Katacoda, and you can see Kubernetes is third in the list, and I'm sure they'll be having more as the time proceeds. So before we straight away jump to what exactly the scenario, I'm going to talk about the custom resources that Litmus uses. I'm pretty sure you guys are aware of it, but still, just to be on the same page, we are the first custom resource is the Chaos engine, which is basically used to link the Kubernetes application to our Chaos experiment, whereas the Chaos experiment is used to configure the parameters that we are going to use in our Chaos experiments, and the Chaos results basically shows the results of our Chaos experiment. It's hooked up to a Prometheus server, which basically shows us which catches the different metrics of our experiment. So yeah, that's the three CRDs that are there. And let me probably close this and get right to the implementation and bring this screen up here. So this is the scenario. So the scenario link is very simple. It's catacoda.com/litmusbot. If you just search this, you'll be getting directly the getting started with Litmus scenario. I've clicked on the one scenario that was there currently, and this is the homepage that we get. So we have a very brief overview of what is Litmus, the CIDs, and how should you use how should you use Litmus, and this is the what we'll be learning in the scenario. So let's just start the scenario, and this takes up at least a minute or half a minute of time. So since I already had it open, the home page, it already loaded up the cloud environment behind. So if you're just directly starting out, it'll probably take 1 minute or half a minute. So that's a thing that's not a Litmus fault or a Kubernetes fault. That's general time that the Catacoda scenario takes to boot up. So let's just check if it's booted up. Yeah, it's good to go. So okay, so to start off with, we'll be running our chaos experiments against Nginx for this particular demo. So we need to first set up the Nginx image basically to run chaos against it. So that's the first thing that we are going to do. So we'll deploy the Nginx application first, and the entire scenario that I'm going to show you today is completely based on a default namespace. We haven't gotten much complicated into it and added custom namespaces yet, but this scenario is completely based on default namespace. So we'll be looking into the exact step-by-step process that I'm going to do is completely based on default namespace. So we are going to deploy the Nginx app on our default namespace, and this is the expected output, which is the same, and the Nginx got deployed. We can actually check for the pods that are there. We should be able to see an Nginx pod, and yeah, so the container is creating and should be created. Okay, it's taking up a little bit of time, but yeah, that's basically it's being created, and this should be created in a few minutes or seconds. So now, in order to run the Litmus experiments on the image, on the application that we just created, we need to install the Litmus operator first. Now, we need to install all the CRDs that we just talked about. We would require service account as well as the chaos operator in order to execute Litmus experiments. So we need to apply the Litmus chaos operator manifest first, and this is the command to basically apply the manifest. If I click on it, it'll set up the service account and the chaos operator. There you go, it already did. We can probably check for the namespace if Litmus is there or not, and we can see the Litmus has already been added. Now for the next step, we'll be verifying if our chaos operator is running on the namespace we just created or not. So if we verify, we'll see the chaos operator has already been installed and it's currently running. Now we can definitely do these verifications. I'll probably do this one. So it's verifying that the chaos, the CRDs that we talked about before this starting the scenario, if those are installed or not. It's just basically a verification step. So we'll basically go ahead and do that. So there you go. We have the chaos engine, chaos experiment, as well as chaos results. This is the API resource, verification of API resource. We'll probably skip that. Now, this is the part where we install a chaos experiment, like which experiment we particularly want to run from Litmus. So we have tons of experiments in Litmus. So probably we can go to chaos hub, and we can see the amount of experiments that we have. So the particular one that I'm trying to give a demo on today is pod delete. It's a very generic one. So we are going to use this one, the generic pod delete, not these. So if you search for any other experiments, you'll definitely find it in LitmusChaos, the hub, Chaos Hub. And these are the details of the experiment that we are going to run. So you will find how you can install the experiment, how you can set up the RBAC, how you can basically see the sample chaos engine. You can of course modify it based on your requirements, but these are the basic ones. You'll of course also see a video where the experiment has been run. So it's pretty much very helpful when you are starting out. So today we are going to do the pod delete experiment. So in order to do that, we will be applying the experiment, the YAML of the experiment, and this is of course on the default namespace. So so this has been created. We can verify if the experiment has been created or not, and there you go. We have pod delete. Next, we need to install RBAC, and this step is required because we need to verify if, like, we need to allow the chaos engine to run experiments on our application namespace. So we need to do the RBAC step. We can probably apply the RBAC and it will take a few seconds, and the RBAC also has been applied. We need to annotate our application, and this is a step. It's a sort of a security measure that we need to annotate our application first in order to check to reduce the blast radius of the chaos operator. And once this is done, we'll see a true chaos result. True should be annotated. So this is good, and we can basically go on and run our chaos experiments now. So let's check for the current pods that are there. We already have the Nginx pod. Now, when we execute the chaos engine, which will run the chaos experiment, we'll see 2 or 3 more pods getting created, and we'll have something sort of this. We'll have Nginx chaos runner created, and then we'll have the pod delete. So let's go ahead and execute the chaos engine, which will start the chaos. And now if I do a watch over the pods that are currently there, we will see that the Nginx chaos runner is already booted up, and we can see it's running. We'll be soon seeing another container. There you go. We'll see a pod delete now, which has been created. And now we need to basically wait for a few seconds before we can move on to the next step, where we can verify the verdict, the experiment verdict. And the experiment verdict will basically say whether the experiment that we are trying to run, the chaos experiment we're trying to run, has been passed or failed, or is it in an awaited state, which means it's still running. So we need to observe the chaos results, probably waiting for this to. Let me continue and try this. So it's still an error from server, so it's still in progress. I can go back and do the watch statement again. So this is what will probably take a little bit of time. Now it's running. I can go to next step, close this, and clear the terminal and see the verdict. And there you go. We have 1 which is awaited, so it's still in await condition. It's still executing. If we keep on running this again and again, we'll see soon enough that the chaos experiment has passed. Okay, this should be good now. So it takes up a little bit of time to run the experiment. Okay, so we can see the verdict, it's passed. So pod delete experiment has successfully been executed, and the status, the verdict of the experiment is passed. So that's that. That's a very brief demo of how you can run the Litmus chaos experiments on Katacoda. This is basically, the whole thing is on cloud, and anyone can go ahead and try. So that's our scenario. It's a very short and simple scenario running on a default namespace. For the future scope for this, we have thought through, and we will be making the different experiments, making scenarios based on different experiments, and also not have default namespace, but also running it on custom namespace, which will be a little bit complicated than this one. So this is a beginner level scenario. That will be maybe an intermediate level scenario where we'll be experimenting on different experiments from the chaos hub. So that's that. And yeah, thanks for tuning in and giving in your time.
Thanks, Ryan. Thanks a lot for that presentation. And we truly believe that having the Katakota scenarios will help the first timers or people who are starting up with Litmus. So without wasting any time, next up we have got Steven. So Steven will be explaining everything on his user story and what he thinks should come up as enhancements. So Steven, the floor is yours.
Yes, thank you. Can anyone hear me?
Yeah, we surely
Yeah.
can hear you.
Okay, good. So hi everyone. I'm a cloud software engineer in a digital advertising company. We have migrated our infrastructure on Kubernetes and more specifically EKS this year, and we are running both front-end, back-end application to manage advertising campaigns, as well as a real-time bidding platform. And that's the, let's say, the most sensible platform we are currently running. So it's a Go application that is supposed to load all the current campaign information, and is supposed to respond to bid requests, and well, let's say under 10 milliseconds maximum, in order to the response to be taken into account by the providers. So it's a really sensitive application that needs to work very efficiently and very quickly. So we have set up all kinds of monitoring and alerting around all this. Also automatic maintenance triggering whenever something happens. We are running so those applications on dedicated Kubernetes nodes. Some of them are spot instances, some of them are on-demand instances. So that's basically the background. And well, recently we talked about yeah, doing some chaos engineering test on this part of the platform, to mostly to check the bottlenecks of our applications, and what would be the current behavior if any kind of incident happen, if we have the correct monitoring setup, if we have the correct metrics set up with the corresponding alerts set up and everything. And so, I took a look at some options, and Litmus seemed like a very interesting option. So I started testing it this week. Actually, I participated in a French meetup last week from someone that was presenting the Litmus platform. And well, I began to install the operator and run some experiments. So my first feeling is, it's very quick to set up and very easy to test different scenarios. I'm thrilled to see all the experiments that are available on the hub, because it's already quite there's a quite complete set of all the experiments already available. So yeah, basically, well, obviously when I run some scenarios like network corruption or network latency, the application didn't react so well. So it was a succeeded chaos, let's say. And some other experiments run very well. And the next step for us will be to, well, try and run some specific scenario. So one of them was to fill up persistent volume claim, or persistent volume, because in the application stack we have a hosted Elasticsearch, and we wanted to check what would happen if we filled that disk. So not the ephemeral storage, but the actual persistent volume where the Elasticsearch data is stored. So I couldn't do this with Litmus. I talked with some people on the community and on the Slack channel. They're going to see what can be done For now, I've just did by hand, with a dd command, created a large file and filling up the disk. And then we'll have to test some other scenarios. My next scenario I'd like to test is the Ec2 termination scenario. So yeah, I'm gonna try and make it work. We don't use. It seems like this scenario is currently backed up, let's say, with Kube2 IAM, which we are in the process of decommissioning because we switched to OpenID service account recently. So I just need to make it work with OpenID, but I'm pretty confident this can be done. And then have to check if we can also experiment some spot termination, well, I know some experiments are really AWS specific, and well, some scenario you can't really fake, let's say, like if we have specific spot instance types that are not in a capacity at the moment. We wanted to try, if we try to boot up a new spot instance but with no capacity, what would happen. So it's very, very specific scenario like this. We also would like to check if, for example, one of the pod loses its IAM permissions. So we have to see how we can do that. We have the whole Kubernetes system failure, but I think there is a kubelet service kill experiment that I could use for that maybe. Yeah, mostly that's our next steps. I need to see if we can share the, let's say, the experiment definition between namespaces, because it seems at the moment, I mean, the way Litmus works is you have to create the experiments in each namespace where your application run. We actually have two namespaces separated with a whole stack with different application in each namespace. So yeah, I was wondering if I actually have to create all experiments in each namespace, but of course creating different engines with different experiment set in each one. Yeah, basically that's it. That's what I've been doing up until now with Litmus.
Awesome, Steven. Hi, this is Karthik. I think we spoke on the channel. Yeah, I think very good requirements. We are looking at improving the suite of experiments that caters to AWS specifically. Sumit is also on the call, and he's also been contributing to that area in the recent times. So regarding the persistent volume fill, I think as we speak, the changes are in progress to be able to allow both the disk fill experiments and the pod IO stress experiments to sort of work with PVs as well. We can specify mount pods. So I think that should be coming in the upcoming patch release 1.9.1. So just wanted to sort of share that. And yeah, really nice to know your use case. I think feel free to create issues on the Litmus repo, and we can always prioritize it for the upcoming releases.
Okay, I will do. Thanks.
Thanks, Steven. Thanks a lot for sharing your story. And next up, as Steven mentioned, that he saw someone presenting Litmus. So the one who presented Litmus was actually Akram Mihai from Vscale. So probably he'll just take up a few minutes to share his experience on the France community meetup. Akram, the floor is yours.
Hello. Well, thank you. As Prithvi has said, well, I'm trying to expand the mindset of chaos engineering in France, and yes, and also I'm trying to expand also the use of the Litmus project, because as I have said in the meetup, that it is a complete framework in order to do chaos engineering and implement the different chaos experimentation in Kubernetes. Yes, and also I will also I think in the future I'm going to do some other meetups in order to more deep dive in the use of this project and how we can all contribute in this project. Yes.
Awesome, Karam, awesome. That was nice to hear, and we look forward to more meetups from you. Before we move on to Karthik explaining the recap and moving on to what we have for the next release, probably I would like to just welcome Matt or Tyler from Everquote. Probably we missed out Matt in the beginning, so Matt can explain his use case or his experience with Litmus as of now.
Hi, thanks. I'm here primarily learning, and I'm kind of here in two capacities. I'm involved with SIG observability in the CNCF, and obviously with Litmus, there's a lot of opportunity to both reason on and visualize and understand and observe what is actually happening when we torture systems or when we apply some of these techniques that Litmus is making available. For our Kubernetes workloads. With my other hat on, I work with Dylan and Tyler at Everquote, and we have a lot of Kubernetes-based workloads, and we're really, at least I'm looking at Litmus as a possibility to help with mitigating a lack of some test collateral to expose bugs and/or issues or scale issues. But again, I'm just watching for today. So thanks for the shout out, and I'm really excited to see what this can do for us.
Hey guys, this is Tyler, also from Everquote, like Matt and Dylan. I'm also observing today, and I'm coming from a little bit of a different perspective than Matt and Dylan, where I'm not ops primarily, but an app developer. So my interest is in both sort of from a quality perspective and enforcing high availability, and then also a dev discipline perspective of being able to truly sort of decouple and not have single points of failure in our applications. Yeah, I guess my purview is from the perspective of a single app developer wanting to make sure that not entirely bound of our application health to like infrastructure changes. So yeah, what you guys have been showing today has been really helpful. Want to start thinking about ways that we can do this at Everquote, and especially ways that we can run as part of a pipeline too, which I've seen like the Katacoda stuff, but I'm really interested to see how, if teams are introducing these sort of experiments into like a build pipeline.
Cool. I think awesome to have you all here. I think thanks for joining in, Matt and Taylor. I think to answer that question, there are folks using Litmus as part of their pipelines. Like we discussed before, there are some GitLab remote templates and GitHub actions that you can sort of use. So people running those pipelines are using the Litmus experiments there. There's a use case within the OpenEBS project. There's a public repo called openebs.ci, which is running the experiments as part of the GitLab pipeline in a couple of stages, one for pod level chaos and one for infra chaos. There's some effort going on around being able to launch Argo workflows that actually run experiments inside. The workflows themselves being triggered by Jenkins pipelines. I think Sumit is actually talking about that in as part of a session in the upcoming KubeCon. So I think that's an area we are seeing emerge. There's also a special interest group that we've sort of dedicated for improving our CI story. Probably provide better support off the bat in Litmus for different CI platforms. So yeah, so that's definitely something that's gaining ground.
So Karthik, just to add that I think we do have provided some support of the basic core Jenkins integration with the Argo pipeline coming in, as we promised that we will be working on the declarative way of calling those functions being made available in the Litmus community. I think anyone who's using that, they can use in place of YAML to the workflow YAML, and then invoking of those workflow YAML via declarative pipeline, which is actually using by Jenkins. So stay tuned. I think Naveen is working on that, and he will be contributing back to the community. We are executing the same way in our company, but we will give back to the community.
Yeah, I'm really interested because I like, it looked to me like some of the assertions were, you know, whether for that pod delete experiment was like if a pod spun down, which I guess like the system under test there is really the mechanism with which to, you know, spin down pods. Whereas for an assertion, again, from like an app developer perspective, it's like, I want to know that, and I see why you might want to like couple this with perf, because it's like, I basically want to know that a random instance can spin down with no effect to the overall health of my application. So yeah, it's like the system under test and then the health are two different pieces. So it's somewhere between like an integration test and a performance test in terms of how it's spun up.
You said exactly the way how it should be, and I think one of the biggest challenges that no one is getting that they are tying in the chaos engineering, which is a more towards the stateful kind of operation, and they think that with the stateful operation we'll get everything. Now, when you add the performance, you are bringing the stateless concept where your system under test is happening, and from outside you are continuously checking that whether there is an impact on the system, your service or application. So I think last community meeting we have shared that recordings will be there, that how we are running the perf and the chaos. And we do have, I think in KubeCon also we are creating the demo Git repo, which will be a good reference to kickstart on that.
All right. Cool. I think we can go ahead and speak about release updates. I see Rahul sort of seems to have joined the call, and he had an agenda item around SIG orchestration that we started yesterday. So as you might all know, within the Litmus community, we're just trying to gather some like-minded folks for working on different areas of the project, which we are also calling as special interest groups inspired by CNCF. There are some groups for improving the observability, CI, and the overall orchestration of chaos and Litmus, and then documentation, etc. We did start one yesterday for SIG orchestration, mostly around contributions to the operator and runner and the admission controller repos. So I think we might get some updates as Rahul joins the call. Before that, I can very quickly go through what were the release items for 1.9. That's the release that just went by. And things that we're looking at for 1.10 and the patch releases on 1.9.x. So are there any questions, any thoughts, opinions that we want to discuss before we get there, before we talk about the releases?
Sure. So sorry, Karthik, to interrupt you. Actually,
okay.
So
Hi, Rahul.
So yeah, so my name is Rahul. I've been leading this chaos orchestration since yesterday. So yeah, so actually, in that SIG group, we have collected all the repos that we need for infrastructure. By infrastructure, I mean the operator that is going to reconcile over the CRs, and the runner that we use for creating the experiments. And then we have something new called the admission controller that we are currently working on. So if you get time, just take a look at the wiki page in Litmus repo, and you will be able to make your way through SIG orchestration. And mainly we're focusing towards improving the resiliency of that framework itself right now. So we are adding a lot of tests, and some of work is going into admission controllers. Like we're developing a new one just to verify all the things. So yeah, we have a lot of things planned around it, and we are like, surely we have to do a lot of things right now. So if you're interested upon that, please go ahead and join that checks, or let me know by mail, GitHub, anywhere you want, or Slack. You can just ping me and I will send you an invite. So yeah, that's about it.
I've just shared the wiki page with the charter for the 6 that we have planned. Some of them are operationalized and some of them are yet to get started. So if you're interested in any of these and want to contribute, want to see release deliverables from this area, then do get in touch. We can always add you to the GitHub team and then send across the invites for these calls, and we can collaborate. All right, with that, let me share my screen, and we'll just go through some of the release items on 1.9. So 1.9 was, as usual, carried some stability features in improvements, and it also had some enhancements to existing features, bug fixes, and a few new features. I think most of our releases have been of that type. It's a little mix of all these things. We released the Alpha 1 version of the Litmus Portal. It is the anticipated UI dashboard for Litmus, and it will help you to run workflows. You will not have to construct YAMLs by hand. You can use a wizard that will sort of guide you to constructing the workflows along with the experiments. More importantly, you'll actually be able to see the workflow in progress. There's some visual aids that can help you notice the stages of the experiments or the workflows being executed as part of the experiments being executed as part of the workflows. And you'll also be able to see the status of these individual experiments within a workflow and the logs associated with it, and the salient events that are occurring. And it also is going to help you construct workflows with weights for the experiments. So in case this sort of ties into a little bit of the CI story, though it's not a direct CI integration. When you're running this, you can actually provide importance levels or some kind of a weight to the experiments that are being included as part of the workflow, so that the final resilience score that's obtained is like a weighted ratio of the pass versus the total number of experiments that have been run as part of the workflow. So that is also being captured, and there is some kind of analytics graphs that you will be able to obtain to see the status of your releases, how a particular set of experiments have been performing over a period of time. So all this is going to be available in the portal. The Alpha 1 version is out, and you can take a look at the portal manifests here, and any feedback is definitely appreciated. It's all available within the Litmus Portal. There's a very good README and a user guide that you can reference from here. So that was one of the things, and we have been making enhancements to our probe infrastructure. This is the one that's helping us to define custom checks. So it's almost like pluggable checks for your experiments. You don't have to construct a new experiment CR or image. You can take an existing generic experiment and add entry level or exit level or continuous chaos checks, continuous health checks that you want to do as the chaos is going on in the background. The enhancement that we made to the probes this time was supporting all the CRUD operations on the K-test probes, and also support what we're calling as probe chaining. So oftentimes you might have probes that are being executed with multiple requirements. So you have one probe giving you some results and probably want to use that as part of the input for the next probe, what we're calling as downstream probes. So that representation is possible today. So there's some kind of a templating logic, very similar to the Helm or Go templates. You can derive the result out of one probe and use it as the argument, or you can use it as part of the command of the next probe, especially in case of stateful applications, anything associated with storage. Say, for example, let's say you're killing the control plane of a storage system, a containerized storage provider. You want to see whether it recovers, whether it's able to continue creating PVs, for example. That's one of the use cases where this is being used right now, but it can have other use cases as well. So we are supporting probe chaining. And another useful feature that has gone in and is actually under development as we speak. There are further changes that need to be done to sort of get the full benefit of this. It is being able to run experiments on external clusters. So you can run the Litmus control plane on one cluster. When I say Litmus control plane, I'm referring to the operator and runner pods. And the actual experiment jobs can be launched on a different cluster. So the chaos runner has been enhanced, or is being enhanced today as we speak, in order to do that. So one important capability was added in the previous release. So that's one of the things that has gone in, all credit to Moti and Onrich. So thanks for contributing this. The other important feature that's gone in is the ability to provide resource requests and limits definition inside of the chaos engine. The Litmus pods, the operator, runner, and the experiment pods are today completely based on Go, and they do not use up much resources. But if you are running in a strictly multi-tenant environment where there are, it's a huge cluster with a lot of namespaces, and there are experiments that are being executed in parallel. In that case, it's possible that there's a good amount of resource utilization, so you can actually provide resource requests and limits, or at least when the push comes to shove, you know what pods are evicted first, and you can sort of control that. And folks who are running in air-gapped environments, or who are running with private registries, maintaining downstream repositories of Litmus components and pushing their images into private registries, we're supporting image pull secrets that you can refer in the chaos engine. These are supported for both the runner and the experiment pods. And all these enhancements that we are talking about for the chaos engine spec and the probes, they're all documented here. You can look at the concepts page in the docs, and you can go to the corresponding section. The component section talks about what all schema enhancements have been made to the runner specification, and experiment specification section talks about all the schema enhancements made for the experiments. So all the resources and other things and probe enhancements, you can all see them here. And we have been in the process of adding some application-specific chaos experiments. So we got a Kafka chaos experiment added, which kills partition reader brokers, verifies that the message strings are unbroken. And we are continuing to improve the network chaos lib. So last release, we introduced support for containerd and cryo runtimes for doing network chaos, pod level network chaos. And we just added the capability to filter by IP or host name in this release. And we also have been working on improving the execution modes of experiment. You can, in cases where the blast radius is higher, you're specifying a pod's affected percentage of, let's say, greater than 0. It's a subset of replicas of your deployment. Whether the chaos on those need to be done all at the same time, or whether they're going to be done one replica after another, one pod after another. So that is something we can define via an environment variable called sequence. Serial is going to do the chaos serially, and parallel is going to affect all the replicas at the same time. And in early releases, we had supported abort only for some pod level chaos experiments, and support for abort in experiments that create chaos processes in the target containers, maybe network experiments or stress-related experiments that inject some processes within the target containers network namespace or process namespace, did not have the abort capability in a proper manner. So this release actually addresses that, and we've added support for aborting even that kind of chaos. So, and all the node level experiments as well now have the abort capabilities, sorry. So that's one of the things we added. And there have been some other minor enhancements. The operator and admin mode are back. That's being used for running all the experiments. So I think Stephen was also referring to this. I think he was saying, is there a need for us to install the experiment CRs in each namespace? That's the standard mode of execution, but there's another mode called admin mode, where all the CRs are placed inside of a central namespace like Litmus. And you would still be creating the chaos engines there, but the application chaos is happening in their respective namespaces. In this case, the service account that's being used is obviously going to be more wide-ranging. It's going to be cluster-wide and has the capability to run all the experiments. So we just pruned the permissions, took a closer look, and we've made it probably less invasive. And there were some enhancements made to reduce the image size of the Litmus experiments. So it's sort of reduced nearly by 300 to 400 MB. So that's a positive. And we also released a tech preview of multi-arc images. So for folks like Michael Fornero and others on the Slack who are working primarily on the edge, so we're also allowing chaos to be done there. There have been some other enhancements on the docs, E2B side deployments. We introduced a Helm file. So it's like a Litmus stack where you can put the Litmus operator and the experiment CR charts, all of them. And we're also going to be adding the portal there. All these charts are going to be installed as part of a single operation with the Helm file. And there's been some additional E2E coverage. Some of the important bug fixes that we've made. The liveness probes based deployments had a problem with the network experiments. We were using the container ID of the application target containers for doing the chaos, and they were getting changed, and we were not able to recover the applications. We've sort of modified that. This was especially seen on Docker runtime. Now we're trying to derive the container ID of the pause container associated with the pod, and we inject our TC rules there. So that's the fix that has gone in importantly. And there are also some enhancements, fixes into the OpenAPI schema validation that we have for the operator and the experiments, and a few other important changes. There are some limitations today for stress experiments that are running in pod exec mode. That is, for folks who don't want to mount the socket files or in their environments, want to do things like ATS API. We do an exec call and run some of these chaos commands. So that is a little bit risky because not all base images or applications will have the same kind of utilities. So we introduced some env variables like chaos kill command and chaos revert commands, etc., which will help you to sort of identify what works on that base image and sort of use it. But we are working towards a better solution for that. And yeah, I think that's majorly what we had for the release. And in terms of what we're looking at for the next releases, there is a Prometheus probe that's coming in to help with the SLO validation in a better way. We're adding taints toleration support in case you're spinning up some nodes on the fly and want to run all the Litmus pods there on that node and then take it down when your CI ends, when your tests end. So in that case, we probably need support for taints toleration, so that's getting added. Some experiments to induce network partitions via KTS network policies. People who don't want to do interface level egress traffic chaos can sort of use this approach instead. And the portal is expected to enter beta, and we're also looking at improving our E2E coverage and docs as usual, incremental progress we're trying to make every release. So on the contribution side, a huge shout out. I think lots of folks contributed either in forms of PRs or issues or discussions on Slack. Everything contributes to the product. So thank you for being engaged and giving us all the requirements and helping us validate them as we build them into the product. Special thanks to Andrej and Sumit and Moti for all the enhancements that's coming around. I think new use cases are emerging. I think I heard the reference of KubeBird project, which probably might make use of the ability to do chaos on other nodes, other clusters, etc. So that's a real positive. So thank you for that. And there's one interesting integration that we got done. So you must all be aware of a project called Captain, which is basically like it helps you to, it's a CD platform, but also has a very nifty feature called quality gates, where you can confirm the SLOs before you promote the application into, let's say, production from staging. And the way to ascertain that Litmus experiments can be used. So there are some, there is a repo here which you can take a look at, and a detailed README which is talking about how you can use the Captain Litmus service for doing that. And there's going to be a webinar that's going to come up about this, and probably you will get an invite for that. So feel free to check this out and share your thoughts. Yeah, I think that's all I had. I think we are, almost on time as well. So if there are any questions, I can probably take that. Yeah, or you can always go ahead and place your questions on Slack, or you can always reach out to us individually as well. I'll probably stop sharing.
Okay, folks, so I guess we don't have any questions for today. So that's all from our side, and that's all for today's call. Also, we will be having a chaos engineering panel discussion coming up on November 7th. So probably we'll be sharing invite for both the webinars as well as the chaos engineering panel discussion. So looking forward to seeing you in the next community call and the upcoming exciting things happening in the Litmus community. Till then, goodbye everyone. Thanks a lot for joining. Thanks everyone.
Thank you.
Thanks, guys.
Thank you.
Thank you. Bye.
Thank you. Goodbye.